temperature on chemical equilibrium. So we want to see the behavior of equilibrium when we alter the temperatures of the system in exothermic reactions and then on endothermic reaction. So this graph is for exothermic and this graph is for endothermic. So we have these examples. For exothermic, it's sulfur dioxide plus oxygen. Then we are forming sulfur trioxide plus energy. Then on endothermic, carbon dioxide plus energy, we form carbon monoxide plus oxygen. So we want to see how the equilibrium position shift when we decrease or when we increase the temperature. So let's see decrease in temperature here. If temperature is decreased, the system responds by shifting to restore the energy. Thus concentration of product increases, because we know this reaction is exothermic, meaning delta H is less than 0. So the forward reaction is exothermic and the reverse reaction is endothermic. So meaning if we lower the temperatures, we are favoring the exothermic side, which is the forward reaction, which is the formation of sulfur trioxide plus energy. So we expect the concentration of sulfur trioxide to increase. The graph for sulfur trioxide increasing is like this. So this is the concentration of sulfur trioxide, SO3. I'm using the square brackets, they represent concentration. Then these are the the graphs for the reactants, because at the beginning of the reaction we had sulfur dioxide and oxygen, but there was 0 sulfur trioxide. That's when you can see the product starts at 0. So we have sulfur trioxide in high concentration, SO2, because you can see with the ratio it's 2:1, so it means sulfur trioxide should be above the oxygen. So this is our oxygen here, concentration. Since we know the equilibrium position is going to shift to the right, it means the concentration of reactants is going to decrease. So the concentration of sulfur dioxide decreases. Then also the concentration of oxygen decreases. See the behavior on the endothermic reaction. Temperature decreased if the delta H is greater than 0. So the concentration of products is going to decrease, while the concentration of reactants will increase. In this case, our reactants are carbon dioxide is the only reactant that we have. Then the products, we have carbon monoxide plus oxygen. So concentration of products will decrease because the system shifts to the left to restore the energy. Then the concentration of products decreases. So let's just have a brief explanation of what is going on the end of the exothermic and what is happening on the endothermic. So on exothermic, if temperature is decreased, then for this endothermic reaction, the system responds by shifting to the right to restore the energy. Then the concentration of products increasing. Then for this side, if the temperature is decreased, for this endothermic reaction, the system responds by shifting to the left to restore the energy. Thus, concentration of reactants increases.